Thank you so much for having me here. I'm Brenna Berman. It's actually particularly exciting for me to come back to Boston because I grew up actually just a little bit down the road. I'm from Western Massachusetts originally, and my parents live out on Cape Cod now, so I get back here fairly often. That also means when I come here that I get to bring family. So my sister is in the audience. And for those of you that work in technical fields, it's a little bit hard to explain what you do sometimes, so it's fun to do a little bit of work in front of your family, and maybe have them understand a little bit. So we do work for the mayor of Chicago, and I do basic operational IT most of the time. I run the email, I run the servers, I run the data center, but I also hold Mayor Emanuel's what we call the innovation portfolio, which does actually, in easy parlance, mean bringing IoT to the city of Chicago. We don't tend to use the term smart cities, though we will when we have to help people understand what we do. And so why is this important? And this might be repeating some things because I think cities have been a big topic for some years now, but why do cities matter? I mean, we're sitting in one now, so some of this is probably a bit redundant, but why do cities matter? Cities produce 70% of greenhouse gases across the world. They also use 70% of the energy consumed globally, but they're also responsible for 80% of the world's GDP. So they're the largest consumers and the largest producers globally. So what they do, how they behave, matters, and they're growing. For the first time in the world's history, the majority of people will live in cities by the year 2050. And so how cities deal with those populations is going to make a difference. How large cities, the advent of mega cities, how we address the increase in population is going to make a difference to both things like global warming, to increased cultural issues like crime. All of those problems are going to be solved or not solved in cities, and technology is going to play a major role in that. So what I'd like to do today is actually go through with you how we're dealing with some of those issues, kind of early in Chicago. Some of them are small examples, some of them are a bit larger, and talk through with you the impact that IoT technology is having. I'll leave some time at the end for questions. And feel free to raise a hand if something comes up along the way. We've got about an hour, so let's use it the best way we can. So what we talk about in Chicago is how we're building a future city, how we're using IoT. So what we define as a future city is an effective integration of the human, physical, and digital systems in the built environment to deliver sustainable, prosperous, and inclusive future for all of our residents, right? Residents, businesses, we do actually care about the tourists that come and visit. It's a growing business for us. And the challenges we face have been changing over time. So there's new challenges now, right? The economic challenges and skills have shifted. Like a lot of cities, the businesses that matter in Chicago are changing. You heard mentioned just a minute ago that IoT represents an opportunity here in Boston, and that's true for Chicago as well. IoT is disrupting all of the major industries that make up the economy in Chicago. We have aging infrastructure, right? Most of Chicago's infrastructure was built between the 1890s and the 1930s, and we're just now getting around to upgrading that. We have a need to sustain our environmental resources. Chicago sits in the middle of the Great Lakes watershed, so how we maintain that resource is extremely important to us. We also have a shift in population demographics. Not only do we have aging demographic on one end, but we also have a growing immigrant population across many cultures, so how we balance their needs is something that we focus on. Shrinking government budgets. I probably don't have to tell you if you watch the news at all. Just like other cities, the need for government services is growing, but also in Chicago, something that's a bit unique. We have a $2 billion pension issue in Chicago, and that's something many cities aren't facing. And one way to close that gap is through the smart use of technology. And then finally, there's a huge lack of support from other levels of government. It probably doesn't come as a big surprise to any of you that support from the state and federal levels isn't coming anytime soon. And something that is slightly unique to Chicago is our relationship with state government becomes more and more strained over time, almost to the point now where, frankly, we actually operate not in an isolated way, but we actually don't count on state support almost at all. And then finally, we have new solutions that we can count on, though, to help address some of those challenges. So we're adopting new service models. We're turning to new models around partnership. Public-private partnerships aren't new in city government, but bringing in the private sector to operate services is different. We're turning to more online service models. The mayor likes to talk about less time in line and more time online. We love to see our residents when we come in, but the less we see them, the more time they're spending with their families or building their businesses. We also focus quite a bit on data-informed decision-making, something that's actually quite big here in Boston as well. We're using predictive analytics and big data to make our service delivery models more efficient. And then finally, we're creating a comprehensive digital infrastructure. So connectivity is a real challenge in Chicago. Broadband is something that we've been struggling with for many years, but we are beginning to invest in full-scale digital urban infrastructures through a massive lighting upgrade, as well as an urban scale sensor network that I'll talk about in just a minute. So that's a bit of the playing field of what we're facing and some of the ways we're trying to address it. So what's our vision? The mayor's been very clear about the role of technology and data from the very beginning. If you think a bit about his background, he comes out of the Obama administration that really pioneered a new use of data, both in his elections and in his administration. So we brought a lot of that to the table in Chicago. So we have a strong commitment to modern infrastructure and smart communities and technological innovation. So we really try to use technology to solve our problems, both downtown and out in the communities. We're partnering across our tech ecosystem, and I'll talk about the roles that universities play, that startups, that large traditional companies are playing in new ways to solve these problems. And we're focusing on fueling opportunity, inclusion, engagement, and innovation for all. There's a strong focus in Chicago in closing what's been called for a long time that digital divide and not leaving anyone behind. We're looking for new ways to do that. So that's the vision. So let's talk about a couple of examples. So like a lot of cities, we have an open data portal. You're probably familiar. There's one here in Cambridge. There's certainly one in Boston. There's others popping up. The City of Chicago's data portal was launched back in actually 2010. But in that time, it's grown to more than 1,000 data sets. Now, for people in this room, you'd actually be able to use that quite easily. There's APIs for each one of those data sets. There's a technical blog that provides updates on the management of the data. So for researchers, for journalists, that data is actually a pretty effective tool. For the average resident, it's pretty impossible to find the answer to a question or to use that data in your everyday life. So about a year ago, we sat back and started to think about the products that we could produce to turn that data into information. So for us in Chicago, we usually always go back to the data, and we launched this tool called Open Grid, trying to turn open data into a utility. And so for people who've used like Zillow to find a house or the mapping function in OpenTable to see what's around you when you're looking for a restaurant, it leverages a lot of that functionality to turn that data into information. So what you can do with Open Grid is actually go out to your house or a neighborhood where you're thinking about sending your children to school and actually see all sorts of location-based city data to understand that neighborhood. What permits have been let in the last year? What potholes have been filled or not filled? What's the crime data like in that neighborhood? And you can search for all of that with many of the same capabilities that people have become used to from general internet usage. You can also draw a standard sort of geometric shape around what you consider your neighborhood. So Chicago has 77 communities that are kind of the standard accepted geographic locations across the city, but people tend to live in neighborhoods that they define themselves, right? The 6 blocks that they live in. And we want them to be able to understand the data around the area that they access regularly so they can draw that shape themselves. This has actually been really important to help residents begin to use data in their day-to-day lives. It's also entirely open source, and the tool's available to community organizations to add their own data to it. It was also designed on a grant from Bloomberg Philanthropies, and the design of it makes it available to cities all over the country. So you could actually open this here in Boston right now. There wouldn't be any data in it because actually the CIO in Boston is working on building this out with open data in Boston, so it wouldn't have any data, but it would actually show up with Boston and Cambridge streets right now. So it's designed for replication. It's been very helpful in making open data useful in the city of Chicago. Oops, wrong direction. So how do we build on that? So we use our own open data to make government services more efficient. There's several examples of this. So this is actually relatively basic predictive analytics, but applied in an urban setting. So one example, which we think makes our residents feel a lot better. So a little bit of background here. We have a little bit more than 15,000 restaurants in the city of Chicago. That doesn't actually include private kitchens like hospitals and cafeterias and schools that also need to be inspected. We have 34 health inspectors. Right, that's a pretty tough balance there. So what do you do? So ideally, you would want them to get to those restaurants that are most likely to have a serious infraction first, right? The goal here being you want to bring down the rate of serious cases of food poisoning. And there's a city ordinance that actually outlines how often we need to inspect a restaurant. That ordinance is still in place. So all we were doing here was actually trying to get to those restaurants most likely to have a serious problem first. Just put the right order together. So this model is based on our 311 data. That's actually one of our best sources of predictive analytics. We have 15 years of 311 resident complaints. And this model actually brings together 34 variables and created a weighted model that actually helps us get to restaurants with serious infractions 7.4 days faster than we did without that model. In the old model, the inspectors would be sent out kind of with a geographic assignment, go to these 10 restaurants down this block, which is great. You do get to the restaurants, but you're not getting to the likely culprits first. And in this way, we were able to bring down the cases of food poisoning across the city faster. And have to tell you, we actually use this model in our own office on a regular basis to check out where we're going on a Saturday night. And now we're rolling this model out across all of the areas where the city does inspections because it's leverageable across anywhere where the city is performing an inspection and we don't have as many inspectors as we need, which is more than 100 parts of our business. We've used this model across rodent baiting, the inspection of illegal cigarettes or the investigation of illegal cigarette sales, and now we're leveraging predictive analytics, which is in a much more complicated space, which is across health and human services. So this has been very, very effective for us. All of this is also built in open source. You can actually go out to GitHub and take a look at it. We do that for a couple of reasons. One, it's cheaper for us to build that way. Two, we like to have the review of data scientists out in the public. We've gotten some really good commits back that have improved our model. And then we do like to commit to, we have a general commitment around the replication of this from other cities. So this model has been replicated to 3 other cities already in the US. And of course, their work improves our work. And then other cities share this commitment. And we've been able to implement we've implemented 2 models from New York in the fire safety space. And we're working on 1 model actually from Boston now as well. So we're able to accelerate our work because of that open source commitment. So that's predictive analytics. I keep going the wrong way. So how do you go from the use of data, which has all been based, those 2 examples so far have been the reuse of our administrative data, right? So data that we've generated from existing city systems that were built for some other reason. So how do you go from that to really the use of IoT and the creation or the generation of new data from sensors? So we're actually doing that in a couple of ways. And one of the best ways, so we've had sensors like most cities for a long time, 10 years or more. But most of the time, they were single-purpose sensors put out into the infrastructure somewhere, out into the lake to do a single reading to tell us one thing. So sensors on the bridge to tell us when the bridge freezes, because bridges freeze before the roads do. And you go out and you salt sooner. That's good, right? But it's a single action that doesn't really give you a lot of insight into a city problem that allows you to build a solution. So we're trying to move beyond that to an IoT-driven solution. And we do most of that work through coalition because these are very, very complex and expensive solutions. And I'll talk a little bit about some of the lessons that we've learned around the complexity of these. So I'll talk to you in a minute about the smart green infrastructure solution, but I want to tell you about where we're building this. So about 3 years ago, we launched a collaboration in the city of Chicago called UILabs. It stands for University and Industry, not University of Illinois. We get that a lot. And it came together to actually on the backs of a Department of Defense grant to focus on the area of digital manufacturing. There are challenges in the manufacturing space in their supply chain that could not be solved alone. So a coalition formed between 17 universities and 35 private sector companies to solve that problem. These are companies that generally compete, but in the space of this lab, they collaborate and then take the learnings outside and go back to competing with each other. The likes of Boeing, Siemens, and Procter & Gamble. Once that lab was set up, some of the partners in that lab stepped back and said, this collaboration model is really working for us. Where's the next challenge where we should go? And their decision was actually around cities, but rather than building an inside lab manufacturing floor, they chose to use the city of Chicago as a living lab to test out IoT solutions in the urban environment. And one of the first places we turned was around green infrastructure. So the challenge here that we're looking to solve, though the solution will be applicable to many areas, was around flooding. So let me give you the background here. Two things have been happening. One, the city of Chicago has a combined water sewer system built primarily in 1890. We have wooden water pipes. I've seen them, wooden water pipes. Yeah, they're great. We've also had, primarily because of global warming, some serious changes in our rainfall patterns. So we get the same amount of rainfall across the year, but it's coming at increased rates. So we basically have bursting rainstorms where the rain is falling at such a fast rate that it's overwhelming our water sewer system, and the result is flooding. Nothing makes a resident more angry than having sewage back up into their basement, let me tell you. And part of the challenge that we've had, so we launched about 3 years ago one of the largest public works projects in the country. It's a $3 billion replacement of our water system. However, and right now the way we're doing it is just sort of a logical replacement across the distance. It's about 100 miles a year. And part of why we're just sort of doing it logically is we don't know where the system is overwhelmed at any given point in time, because like a leak in your house, the leak might be in your kitchen, but you don't actually know where the water's coming in through your roof. This solution is going to give us better information about two things. One, there are sensors in our deep water system which will help us understand where the water system is becoming overwhelmed when it does rain. We've also put in place 6 green infrastructure solutions that will divert rainwater from the water system into other parts of the city. So these are things like permeable ground cover in parks and bioswales, which are these graduated hills that capture the water and move it away from the water system. Part of why there are 6 pilot locations is they are all different examples of green infrastructure. And the reason there are different ones is this is something that the city is more than willing to invest in, but they're all quite expensive, and we don't know which ones are going to work the best. So you want to actually collect some data about that. So the sensors are in the water system and in each of the 6 potential green infrastructure solutions, and then there is a secure network to collect that data and transfer it back to the lab for analysis and evaluation. The pilot started about 4 months ago. It's a 12-month pilot, at which point we'll be able to make some decisions that will both help us evaluate which of the green infrastructure solutions we want to replicate across the city and where they're most effective, and should provide us with some data to adjust the underground construction plan so that we can target those places of the water system that are becoming overwhelmed first and address those flooding problems. So this is sort of truly an IoT solution in place. Also at the lab City Digital, which is the city version of UILabs, solving another problem, which is actually not sensor-driven, but is using a different kind of data-driven technology, is a project to solve an underground mapping problem. So this is something that we've all experienced, which is getting stuck behind construction. And part of why construction in the city space is so complicated is all cities have very little information about the inventory of assets underground. So we have some, portions of it are always still paper-based. Even if it is digital, the information is limited. Very few cities actually have complete information of what's underground for a couple of reasons. One, they tend to have X and Y information, but rarely do they have Z, like depth information of those assets, which just makes it less helpful. It also tends to not get updated over time. So if a construction project occurred 15 years ago and there have been any adjustments, those were probably not captured. And then finally, there are underground assets that are actually no longer owned by the entity that installed them. So for example, in Chicago, we have US telegraph pipes underground, and that company doesn't exist anymore. So I guess the city owns them by default, but we certainly don't have a map of where they all are. This complexity actually, to give you an idea of the impact of this problem, there is an accident caused by someone striking underground infrastructure across the US every 60 seconds of every day of the year. So at worst, those accidents increase the cost of the project and the delays, et cetera, that drive all of our residents crazy. At worst, those accidents are running into a water main or a gas line that cause an explosion, and you can attribute about 1,000 deaths a year to these types of accidents. So these are very serious problems. It adds up to about $2 billion in cost a year from construction delays and medical costs. So this is a very serious problem. But what do you do about it? Well, you try to create a better inventory. This is a very complex inventory. You want it to be digital, you want it to be secure, and you need it to support collaboration. In Chicago alone, there are 27 entities between the city and the utilities that actually own this infrastructure and that you need to collaborate in their planning. So what did we do about it? I think I have an additional picture. So you work with the university. In this case, it was the University of Illinois down in Champaign that had adopted some very interesting LiDAR technology to drive, and I get this word wrong, and there's going to be an engineer in here that knows how to pronounce it, called stereoscopy, that is able to take a picture. So this is an open hole, actually about a block from my house in Chicago, that's able to take a regular digital picture of underground infrastructure and break that up into millions and millions of tiny little digital dots. And then you use that technology to reconstruct that and refine it into a point clouds into 3D objects. So this is a color-coded representation in a highly secured database of exactly that little square, which I'm not sure you can see that, in the middle of that picture. That pilot project, which took us about 4 months just to create that one, proved that we could actually create a scalable database of our entire underground infrastructure. This took about 6 different participants to go from the actual digital photography technology down into the secure database, which now we move into pilot to be able to scale that for a 3-block area. And that pilot will also include the business processes required to manage that across the 27 players. But the value of this, I think, is very clear because of the problem that it will solve. There's also some interesting revenue implications here, because if you know where all of the assets are, you can actually permit properly and charge properly for those permits. So the city's very interested in this, not only to control our own construction costs and improve the safety for our workers and the residents, but also to be able to manage our partnerships with the utilities in the city. There's also obviously, so one note about the City Digital Partnership, this is a co-development partnership that drives revenue sharing contracts, so we will be selling this to other cities, and we have 8 that are already interested. Leading that pack, not surprisingly, is the City of Rome. Because if you think we have complex underground infrastructure, right, we don't have catacombs or aqueducts. And then the last thing that we're working on there, which is actually a much more sort of traditional, I think, use of IoT, is, we talked a minute ago about the use of Nest and some of the residential uses of IoT in our own homes. I myself have a smart washing machine, which I find really interesting. It will tell me when my laundry is done, or it will tell me when I need to adjust the level of fabric softener, which I think is really interesting. It's odd when someone else knows how clean my clothes are. But the scale of that for a commercial building and the scale of that for the entire city, or even just the footprint of the 200 and some odd buildings that the city owns, is actually quite impactful. And so we're applying a smart building data service to some really interesting projects in the city of Chicago, like how we build the smartest library in the city of Chicago, which has several layers. So a common use of this is how you include IoT data management services in the construction of a building to ensure the sustainability and energy management of that building. This has actually been going on for a couple of years, but then how do you translate that into the technology engagement with the residents that will be using that library, which gets into actually some of the retail IoT in a public space. So people come into libraries for very different reasons depending on the neighborhood that you're in. Some people still use their libraries very much for knowledge acquisition, right, for the book lending aspect of it. But in many of our neighborhoods, the library is much more of a community center. So how do you bring people into the library? How do you engage them while they're there? And how do you, in very much sort of retail parlance, increase their basket of goods while they're there? But how does that translate to the public sector? So that's quite a bit of some of what we're doing around smart building data systems, to go from using that to manage the energy footprint of a building and the proactive maintenance of a building, to use these data systems to understand the people that are using them and how they're using them, and use that data to improve the relationship of the services we provide with the residents that are using the building. So then these were all, if you think about them, those were individual IoT projects targeting a specific business problem that the city had, right? Flooding and green infrastructure, an underground mapping problem so that we could understand our infrastructure and drive better construction projects. But there are problems facing cities that are much broader in nature. And you have two examples here. So what you're seeing there on the left is, and that's sort of the greater Chicago area. In each one of those dots are where we actually have temperature sensors. That's actually, and I don't know how many miles that is, but that's more than about 1,000 square miles, and there's like, what, 8 temperature sensors there? That's actually not really good data. Even if you're just trying to find out if you should put on a sweater or not, that's actually not really helpful. God forbid if you're trying to do any research. And then on the side there, you actually have sort of a futuristic picture of what an intersection looks like. And I put that up there for two reasons. One, we actually are thinking a lot about what the advent of driverless cars is going to look like in Chicago. And driverless cars depend on the interaction between the car and the infrastructure, which is not actually anything our infrastructure can handle right now. And then also, Chicago is a participant in the Vision Zero initiative, which is the commitment of cities to drive pedestrian and vehicular accidents to zero by, someone help me, is it 2020 or 2050? 2020, I think. And we don't actually have the information to inform that. So on the accident one, when someone has an accident, you have a huge amount of data about that. There are medical reports and police reports and insurance records. You have no information around near misses, which are arguably much more interesting than the accident itself. So how do you fix those two problems, which arguably are, we don't have enough granular data about the city's environment, infrastructure, or activities to drive the advanced research that we want to do to move to that next level of being a future city? Well, you build an urban sensor network to collect all that data. And that's what we've done. So this is the array of things. And this is a 3.5-year project that was a partnership between the City of Chicago, the Argonne National Laboratory, and the University of Chicago. I'm very close to the dates on this because I had my first meeting about this the day back from maternity leave, and my son will be 4 in January. So I was able to grow a human faster than I was able to do this project. And I only point that out because I actually had a really quick chat with a gentleman at one of the tables outside. We were talking about what's harder, hardware or software. This is the integration of both. And the hardware was actually really hard. So what does it do? So when I say this is an urban scale sensor, in 2018, when the rollout of this is complete, there will be 500 multi-sensor nodes in clusters across the city of Chicago. So what is it collecting? There are environmental sensors collecting air temperature, humidity, barometric pressure, vibration, sound intensity, and a magnometer, sorry. There's a large focus on air quality for various reasons, multiple air quality sensors, so nitrogen dioxide, ozone, carbon monoxide, hydrogen sulfide, sulfur dioxide, and we've recently introduced, so across the 500, there's a 50-50 split between a pollen sensor and a diesel sensor. Those are both actually extremely expensive, so we had to split the baby on that one. There are light and infrared sensors going after light intensity, and an infrared camera that points up, collecting images of the sky. There is also a camera that points down, which is designed to capture still pictures to allow us to calculate information about vehicular, pedestrian, and bike traffic, as well as information about the condition of the roads and the sidewalks. There is a microphone, which is actually only sensitive enough to capture changes in decibels. It does not capture conversation. It's not that sensitive. And then what's actually out? So most of those sensors I just described and the downward pointing camera in that beehive shaped thing, which is a Stevenson shield. Inside that, there is this little knit sock to protect the sensors. It took us quite a while in terms of design to figure out, given that these things will be outside for multiple years in the elements, to figure out how to protect the sensors enough to survive, but to allow the airflow required for them to collect the data. And then in the box that you see there is power. These run on about as much power as required to charge your cell phone in a year. There is compute power because the image processing is done at the edge, right in the node. There is Wi-Fi because these are a Wi-Fi network holding them all together. And then the upward pointing camera is actually in the box and not in the little beehive. So why are we doing this? And because they require 24-hour power, they are on traffic poles as opposed to light poles. Light poles in Chicago do not have power 24/7. So these are all at intersections across the city. So why are we doing this? So in general, these are to collect a detailed level of information about our environment to allow us to do a level of research we've never been able to do. There are specific use cases that we are already working on. So the first one of these went up at the very end of August, just prior to school starting. We have roughly 28 of them up now, and the pilot group is 42. We should have 100 up by the end of this year, and as I said, 500 by 2018. There are use cases that the city is already committed to doing. One is that research around the interaction between vehicles and pedestrians that are near misses, right, but not an accident. We're extremely interested in standing water on the roads. So residents will call when that water is in their basements. They don't call though when there's a major puddle on the street, but that has no effect on their yard or their house. And so we don't always have a lot of information about where there's standing water, which is an indication of a failure in our water sewer system. So we're very interested in the condition of the roads. And then we also plan to actually do quite a bit of work. So the air quality data is obviously very interesting to us. A lot of that research is being done through partnerships with health clinics and the University of Chicago. We have some interesting partnerships already going with, we're a large bicycling community. They're very interested in some of that air quality data, the ability to make decisions about bike lanes, et cetera, that avoid places where the air quality is worse versus better. All of this data will be open data and available to the public on the city's open data portal. So this is a very public project. The last thing I would add about this, because I think the obvious question is, the obvious question that I tend to get, so I'll go ahead with it, is about privacy, because there is a camera. Yeah, so I'll put it out there. There is so first, how the images work. When I said all the data would be public, so this is how, the cameras are taking, so the upward facing cameras are taking pictures of the sky. There are no people in those pictures, so we're not worried about those. The downward facing pictures will capture pictures of cars, of pedestrians walking down the street. Those pictures are processed in the node. There are video analytics that have been and are under development by scientists at UILabs that will process those pictures to take counts of the objects in the picture. This is an experimental project. Our best estimate right now is that processing will take about 4 minutes. Once the processing is done, the images will be destroyed, and it is the counts that will be transmitted back to the database at the lab, and it is those counts that will be shared as open data. Obviously, none of those images will be shared because they will be destroyed. There is a privacy policy that was developed with some expert input from likely parties like the ACLU and EFF. That privacy policy was then vetted publicly through through resident meetings, et cetera, and is available on the Array of Things website. So there is a very sort of clear and, we hoped, relatively simple privacy policy that speaks to what data is collected and how it is shared and what is available, and that's on the website today. And we committed to that privacy policy being completed before anything was installed, and that was the case. So the images are deleted once they are processed. It is the data from those images and not the images themselves that is shared, and the privacy policy is available on the website. And surprisingly, that was actually not the question our residents had the most. Because of the, not probably sharing anything surprising to anyone who reads the paper, because of the situation we're having around police violence in Chicago right now, most residents were concerned we weren't using this for surveillance, not that we might use it for surveillance. But most questions we got from residents were how they made a request to have these put in their neighborhoods, what services the city was going to provide to help them use the data. So we're beginning to think through now how to build those partnerships. And I think the last thing that I would add about this project, before I get to that one, is there's a high school STEM curriculum built around this project. So every time these are installed in a neighborhood, there's a two-piece curriculum that is built into the neighborhood high schools. One is around the physical structure of it. So there are high school classes that get to build their own version of this. It's entirely open source. They build a slightly lower phi version of it, and they get to put those up around their high school or out on their campus and compare the data they generate with the data being generated out in their community. And then there's a part of the curriculum for their biology class that lets them use the air quality data being generated by the nodes out in their neighborhood in that class, where they get to apply their skills to the data analysis in their biology class. So it's pretty excited, and we're excited to see how this grows, and I'm most excited to actually see what comes out of the data as it's picked up by community groups and our civic tech community, and how that data is used, because we know how we're going to use it in the city, but I think it's most exciting to see how it's going to be used by our community partners. So the last thing I wanted to talk about was actually the partnerships that are required to make IoT projects work. The city could actually not do any of this on our own. All of these are actually more complex than anything we could do. So what you're looking at here, just for those of you who may, is it very traditional. This is the map. If someone said, well, what does Chicago look like? This is a traditional map of the city of Chicago. These are our 77 neighborhoods. I live on the near west side one. And this is what most people look at. This is actually how we look at it most of the time. So Chicago, which is the star in the middle there, we love our star, it actually has the world's largest commercial internet exchange point by volume, right? Now, a lot of those are commercial. I don't get to use those. That would be pretty awesome. I think from my perspective, a lot of this is the high-speed trading, but there is a very strong IT view of the city of Chicago that we try to embrace and that we're using to cultivate economic development, but it's the partnerships that matter. And those partnerships have become broader and broader over the last 5 years. We have what I feel like is one of the most vibrant civic tech communities that you would find around the country. On any given night, there are meetups across the city of Chicago that turn up between 100 and 500 people willing to either apply their existing sort of daytime tech skills to civic challenges, or people who are not traditional tech people, so like the accountant by day, coder by night. Those are my favorite, people who are not techies in their day job, who happen to code, who show up to help us. And so we have a huge amount of support from our civic tech community. And I think some of the best work that they do is the pressure that they apply to city government for us to do things for them, which is great. The success of our open data portal, I think, has been entirely due to the pressure that they provided on us to publish data for them. And without that, we would not have been so successful. We have excellent support from both local and global philanthropies who are willing to fund data-driven and technology work. I think there's been a slight shift from philanthropies who want to fund mission space work around child welfare, et cetera, to philanthropies who are willing to fund technology work, which is very exciting. We have committed community service organizations that are willing to focus on tech-driven improvements around the cities. Our partnerships with academia and national labs is actually probably, not to offend the other groups, but they're not here, is probably actually the most important supporter that we have. We have very strong partnerships with major universities in the city of Chicago, so Northwestern, the University of Chicago, U of I, but we also have partnerships with universities actually outside of Chicago, which always sort of amazes me. Like you like to point out to USC that they're not that far from LA, that they could work there. But if they want to work with us, I'll take it. We also have changing partnerships with corporations. So it's normal for corporations to want to give back to the cities that they're in, and that give back used to be, let's go on Saturday and clean up a park or help paint the YMCA. We now hear from them that they want to use the skills that they have to give back. So a good example for us is Allstate, right? Very large insurance company based in the suburbs of Chicago. We get 10 hours a week from their data science team, which is 115 people. Think about that for a minute. I know. It's a huge team, and that's been a 3-year commitment for them. And so sometimes actually we're building a joint project that's as much benefit to them as it is to us. So we worked on a model around using weather data to better deploy resources after a storm, right? Good for us because I needed to get people out there to clean up after power lines went down. They need to get their adjusters out. Made perfect sense. Sometimes it is purely pro bono, and for them it makes sense because they have people from a retention perspective that they want to give good opportunities to, those feel-good opportunities that make them happy to have their job, and I have access to an extraordinary data science team that augments my relatively small team. We work across levels of government with the county because we sit on the same footprint, and then the startups, which I mentioned before. And then finally, the collaboratives. I mentioned UILabs. There's one other that is extremely important, which is this organization called the Smart Chicago Collaborative. Their entire focus is on making sure that technology is adopted by all of the residents in the city of Chicago. They are our partner when we do resident engagement, and they are incredibly good at it. They have well-established methodologies that are proven to drive adoption among residents. They were our partner when we were working on the privacy policy for the array of things. They host a thing called the Civic User Testing Group. We do end user testing of all of our applications directly with our residents, and that's hosted by them, and it changes the quality of your output. So without this civic ecosystem, our projects would not work. So finally, a couple lessons learned for people who are considering IoT projects, whether you're in the urban space or not. There is no secret sauce. These projects are hard. I think you guys all know that. We always start with a business challenge. I never have the luxury, nor do I think it's the right thing to do just to build shiny technology. It'd be fun, but we don't get to do that. So we always start with the business challenge or the problem for our residents that we're trying to solve. We always focus on the value that we're trying to create, especially in the communication, because almost no one that we're ever talking to actually understands what we're building, let's be honest about it. We do focus on the interoperability, and while there aren't that many established standards yet, the standards that we're moving towards, because especially as you're building multiple solutions, sometime in the near future, all of these things are going to need to talk to each other. We engage our stakeholders as early as possible because pushback from those stakeholders can kill a project at any time. We also vary that approach depending on the project. So the projects that you've seen here, like for Open Grid, which was a relatively simple application that was much like internet applications that they've used in the past, that one we just did basic end user testing. Not a lot of stakeholder engagement up front. The two other examples that you saw around green infrastructure and underground mapping, those are fairly transparent to our residents because they're not going to see those. We incorporate those into an IT education program that we run through the library. So they're examples that they understand, but they're not anything we do really outward engagement about. The array of things, we've been doing engagement around that for 2 years because that's something that they're going to see in their environment that could make you very nervous. So we've been upfront and out front about that since the very beginning. Think carefully and early about privacy and security. That we need to say, and I know we have sessions about that later. And then I would say just start. Pick a small project, get going. Don't try to boil the ocean beforehand because you'll never get started if you try to figure it out all at once because it's just not possible. And thank you all very much. I appreciate the time. If there are any.
So I love the Array of Things project, and I'm just trying to wrap my head around the goal of detecting these near misses
Yeah.
with the fabulous work on protecting people's privacy.
Yeah.
So if all you get are counts, how do you do the near miss analysis?
So that's a very good question. We do have 2 scientists that will have access to a subset of calibration pictures. So there will be less than 1% of the pictures that are stored to allow for that research. Yeah. So they'll be able to do some distance measurements. Yeah. Please.
Yeah, I wanted to ask some more about the privacy and security. So you mentioned it at the end with the cameras, but earlier also you were talking about with the underground mapping, how everything goes into a secure database. And my question is, how do you think about who has access to that data, for what purposes? How do you think about mission creep when people come up with ideas for using that data in ways that you
Didn't know.
You didn't
Right.
initially envision?
Yep, so for underground mapping, none of that data is public because those are all either city or utility assets that are highly secure. So that's all relatively traditional role-based security, and you have access to what your role allows you to have access to. For the array of things, there's actually, and this is in the privacy policy, there's a governance structure that includes I'm gonna get the name wrong, but like a scientific evaluation committee. So because we expect the scope of that to grow, like by definition, especially because there's an aspect of that project that allows new sensors to be introduced over time. In fact, there's room for 25% more, and we also expect some of the current sensors to sunset over time. It's designed a little bit like a bookcase. When you're done with one book, make room for more. But there's a process where a researcher or even a corporation can submit a proposal, and if that sensor, depending on what it is, triggers security concerns, there's a security review by an external party that's actually run out of the University of Indiana that makes a recommendation around the security implications, and then those recommendations go to the overall governance committee, which is chaired by the CIO, which at the moment is me, but by the CIO and the lead researcher at the University of Chicago. So there is a process to manage that.
You talked a little bit about the digital divide and struggles that the city has had with broadband access.
Yeah.
Can you talk a little bit more about the lighting upgrades you guys are doing?
Sorry,
You had mentioned.
the lighting upgrades.
Yeah.
So the city of Chicago is actually the most well-lit city in the U.S., if you view it as a good thing. We have 480,000 streetlights. So we are about to put out the RFP to do the LED upgrade for those lights. And there's it's roughly like a 50% payback on that. We are working through the dynamics of using that to have that upgrade result in a Wi-Fi network. The challenge for us though, because in most cities, frankly, that's like a no-brainer. But part of our challenge is the infrastructure of the light poles is so old that 50% return on the LED savings is barely enough to actually handle the lighting infrastructure upgrade. So for us, it's not as easy a no-brainer. And we're more focused on using as much of that as possible to get to the adaptive lighting because of the savings and the public safety implications of the adaptive lighting. But that's our hope, is that we'll be able to get the citywide Wi-Fi network from that. But our challenge around broadband is we have neighborhoods that are still very poorly served for high speed.
What's the fiber infrastructure for the Wi-Fi that you do the lighting?
For the lighting, that's actually part of the challenge, is we're still trying to figure out the right architecture for that. Yeah. Yes.
In addition to your major infrastructure upgrades, cities are digging up streets all the time.
Yes.
Are you using that opportunity to either put in conduit for fiber or to put sensors or do something as you do the normal day-to-day stuff?
I wish we were. I agree with you, that is the right opportunity. That's when we should be laying dark fiber or whatever. There's a challenge around the cost. That is absolutely the cheapest time, but our budget is such at this point. So I think it's both a budget and a cultural problem. There is almost no available budget for that, and it has been hard to find the right ears for that message to land on, to be completely honest about it. Did you have something?
I was just wondering about the granularity of the array of things sensors. What ideally, or like what is the ideal amount of sensors you would have like per city block?
So we're not actually, so the challenge we've had is with 500 sensors, we're about 500 square miles, so there is this dangerous one-to-one assumption people make. They're being deployed in clusters around problems, and we define each cluster by 3 things. There's usually a research problem that has a university or some other research organization partnered with it. There's a community problem and then a city policy problem that we're looking at. So they'll be deployed in clusters and not sort of evenly across the city. Does that make sense?
Could you make any comments about closing the loop on quality of life, specifically, for example, like the information you're gathering on noise level, its impact on stress, and perhaps treatment, closing that loop with the health community?
Yep. So that's definitely in focus, and it's both for noise level, air quality. So first, you need to actually figure out, you need the data first to understand. Then there's the treatments around it. So reviewing this is sort of a long time or a long range problem. Specifically around noise quality, one of the things that's going to be interesting is we've never had noise quality measures except around the airport. And we have one particular neighborhood that is a combination of sort of tourist attractions, restaurants, et cetera. It is residential, and there's 2 major hospitals and 2 fire departments. So they are convinced that they have noise quality issues, and they'd like to institute a curfew, or like a noise quality curfew. They've had no data around that. So it will be interesting because this will allow us both to determine if the problem is real, put in place or pilot a treatment, and then actually determine if the treatment is having the desired effect because we'll have the data to close that loop. And we'll be able to put similar sort of programs in place around air quality. Urban asthma is one of the air quality issues that we're definitely interested, especially in neighborhoods that have the highways going through it. So that's the structure that we're going, and why we have research partners in place for all of those, because that's a particularly difficult loop for a city to put in place, especially given the administrative timelines that we tend to have, because some of those won't close in the 4 years that we tend to have. That's the plan.
So there are concerns oftentimes when we use data to make decisions that affect people, like where to deploy our resources for policing,
Yes.
things like this. Right, because the data might reflect existing
Bias.
problems or decisions that have been made in the past. My question is, it seems as though you had maybe 2 very qualitatively different types of data in what you talked about. If I understood correctly, the restaurant data was found data that represents existing policy, perhaps.
Yeah.
And it seems like the array of
things, yeah.
sensors is new data. And it seems to me that feels helpful from the perspective of using data for policy.
It does.
I wonder if you could expand on.
So there's a known bias especially in 311 data that cities deal with all the time. So 311 calls, frankly, only come from neighborhoods that have the luxury of not calling 911, right? So we don't, and so one of the solutions we didn't talk about was predictive rodent baiting. And that example, I think, highlights exactly what you're talking about. So we used almost a very similar algorithm as we did with restaurants around rodent baiting, and it came from the same data set. So we know that there is bias in our 311 data. Those calls come from our more economically well-off neighborhoods. However, you can sort of model for that problem in the use of the data. And what was I think, the best outcome with the predictive rodent baiting is that project there was a 20% efficiency in the application of that model. It basically allows us to identify where we're likely to get a rodent call about a week before. It's only coincidence it's about the same measure, but about a week before the call actually comes in, so we can go out proactively to bait so the rats don't come above the surface is essentially what we're after. We were able to, because the model had addressed the bias, the model is actually accurate across the entire city, whether we had historical data for that neighborhood or not, and we reinvested that 20% into the service, which allowed us to expand the service citywide. So you can, in administrative data, you can address things like bias. What's nice for the array of things is because it's organic collection, we shouldn't have those problems. You will still want to evaluate it for that problem.
I'm interested in your make versus buy decision process. You mentioned most of your Many of these applications are also being pursued by commercial entities. How do you make those decisions?
Some are and some aren't. So for rule of thumb, I mean, if I can buy it, I would prefer to. I mean, my shop is actually not good at this. On the analytics side, though, my team is actually very good at it, and most of what we're doing, we actually can't buy. So like the development of an algorithm, you actually can't buy. I mean, we could contract for it, I guess, but frankly, most of the time you can't afford that, and the amount of time you would spend teaching that consulting team what my team already knows isn't worth it. With the array of things, nothing like that does exist. We actually can't buy that. In other areas, so for the underground mapping and the green infrastructure one, the partners in those projects are the likes of Microsoft and Accenture. Siemens is in one of them. So there are components in those that are commercial products for them in other industries, or pieces of cross-industry commercial products that we're integrating together in a new way. So there are commercial products in those, but that are sort of being repackaged for a specific use.
So let's take one last question.
Sort of tailing off of his question, thanks, Scott. When you started this pilot, did you have an intended product life cycle in terms that was meeting a cost or business case target in terms of how often these array of things nodes needed to be serviced, replaced, upgraded, etc.?
So that's actually one of the things we're testing. So there's sort of two parts to this pilot. One is the data aspect of it, right? How accurate will the data be when we collect it? Some of those sensors are actually highly experimental. Like there's 3 different temperature sensors in there. So there's an aspect of the pilot around the sensors and the data itself, and then there is an aspect in the pilot around the hardware, because the part of the pilot around the longevity of that hardware in the environment, et cetera, is the other thing. So we don't know. So we have baselines, et cetera. This will be our first winter. So that's one of the things that we're looking to pilot. The general model around it, though, is a sort of swap maintenance model, because all of the installation is done by city electricians. So it goes up whole, it gets strapped on and plugged in, it comes down whole. So that is one of the things that we're actually looking at. Great.
Great, thank you.
Thank you very much. Thank you.